It's electric!
Introduction to Electrostatics. Today we kick off our study of electricity with some basic notes on how one of the fundamental forces of nature works, electricity. From early cavemen striking flint rocks together to start a fire, to watching lightning streak across the sky, to modern electronics, which makes our life so convenient. Electricity is a fundamental part of nature and our world that makes our lives so much easier. So let's kick off with some definitions. The first is, what is static electricity? Well, there are two main types of electricity we're going to study. In this case, we're going to start off with static. And the reason why is static is easier. Static means stationary, not moving. So in the word electrostatics is this idea that we're going to look at electricity at rest. Versus current electricity is when you get those electric charges to move. And all of modern life is controlling the flow of charges and electrons to make our lives easier. Sending texts, tweets, taking pictures, etc. So a good analogy we often use is water. Just like water can flow in lakes and rivers, so can electricity, is the analogy there. So in this case, which would be a better analogy for static electricity? Would it be a lake where the water is sitting there still, or like a river? And obviously, right, if you got something flowing, that would be a river. That's current electricity. In our case, we're going to start off with static electricity, so it'd be more like a lake. And interesting enough, in terms of historical fact here, Ben Franklin came up with the system for charges that we still use to this day, and the terminology of positive and negative charges. So moving on, let's talk about electric charges and forces, nature's glue to hold the universe together. So Ben Franklin came up with this terminology, which we still use. There are two flavors of charges in the universe. There's either positive charges and negative charges. And the rule is pretty simple. You've probably heard it before, that like charges will repel, while opposite charges will attract. Likes repel, opposites attract. So a positive charge will repel a positive charge. A negative charge will repel a negative charge. But an oppositely charged positive and negative object, they'll attract each other. Opposites attracts, likes repel. So in terms of how the universe is put together, this is what nature uses. Nature uses electrical forces to glue together all of our atomic elements. So a little basic chemistry here. If you recall, all atoms are composed of three basic subatomic particles. We have protons, which are positively charged, and they are tightly locked within the nucleus of an atom. We have neutrons, which have no charge, and they're also found in the nucleus. And what holds these particles together is there's what's called a strong nuclear force, because the protons want to push apart. And then on the outside, we have electrons, which are relatively loosely bound, and they're held in orbit by the opposite charged protons with the negatively charged electrons electrically attracting each other there. And usually atoms like to be neutral. So if you have 4 protons, you're going to have 4 electrons. If you have 8 protons, you'll have 8 electrons, etc. And if you have an excess or deficiency of electrons, you get a charged ion. So if you have an extra electron, it would be a negatively charged ion. If you're missing electrons, it would be a positively charged ion. And a lot of what you study in chemistry then is about how different atomic elements will bond based on their electrical properties. So a little concept check for electrostatics. We have 2 charged balls that are repelling each other, and they're hung from the ceiling. What can you say about their charges? And this is something you're going to get to try in class, in lab here. The first is one is positive, the other is negative. The second is both are positive. Third possibility is both are negative. And the last possibility is both are positive or both are negative. And one simple way you can try this actually is at home. You don't even have to use special physics lab equipment. If you just rip off 2 pieces of Scotch tape, they're going to actually grab charges as you peel them off the roll, because the sticky side of the tape and the plasticky material of the Scotch tape, they actually like to grab electrons off the surface here. So anyway, let's see if you can figure this out.